Okay, now we have calculated all the Parafact2 models and we need to look into what has happened. But we actually made a modeling of a dataset where we had all the intervals chosen. So I'm going to load the intervals that I chose at that time, and they will be in the project folder, which is this one, and they're called intervals. So when I load that, I'm going to get a list of all the intervals. And as opposed to before, you now see that we have a list of how many components were calculated in each interval. And also now the status is 2, indicating that I have already fitted a Parafact2 model to each of these intervals. So I'm going to go and evaluate these models using the Evaluate Models button. Because for each interval I have to select how many components are there, and not only that. So I'm going to maximize this one, and I have to load the result. And the result is also in the project folder, and it's called models. So let me open that. Now we used a lot of intervals and we have actually been going through them, but we're just going to go through a few of them here. So let me start with, for example, interval number 2 to show you what is going on there. After waiting a little bit, you get a visualization of the Parafact2 model. Now remember that so far we don't actually have a model, but we tried to model the peak, which is shown here, under the assumption that there was 1 chemical compound, 2, 3, 4, 5, 6, 7, 8. And we have to figure out which one of these are the right one. Now, to do that, there are 3 plots that we're mainly using. The one called fit, core consistency, and residuals. And you can say that for the fit, we want to use so many components that the fit is pretty high. Now what does pretty high mean? That means close to 100, more than close to, for example, 90, depending on your data. But we typically want it to be very close to 100. So anything above 3 here is probably fine. There's another plot which is called the core consistency. It is a measure of how adequate the Parafact2 model is, and the way it works is that it supposedly stays high for as long as your modeling is going fine, but once you take too many components, it's gonna go towards 0 or even below 0. So what you want to do in terms of the core consistency is that basically you want to pick the highest number of components that still has a sufficiently high core consistency. And a sufficiently high core consistency, well, you like it to be close to 100, but in fact you probably have to accept anything that's closer to 100 than to 0. But if you get, for example, let's say we had a core consistency of 50 or 60 here, then you would have to look into that model, but it would be an annoying case indicating that the model was a little bit shaky. But you do prefer anything that's closer to 100 than to 0. So these are 2 of the tools that we have. Let me show you how the model would look if I had only taken 1 component. So I can turn down the number of components by pressing here 3 times, and it's going to take a little while before it changes. Now you see, now we have the red circle at 1, indicating that we only use 1 component. This is the illusion profile in each sample of a 1 component model. These are the actual tick illusion profiles. And you see that the residuals have a lot of structure left in them. The residuals would basically be this minus this. And because there's still structure left here, we are inclined to say that this is not a nice model. And the fit will support that. So we want to go up higher. So let's move on up to 4 components, which I believe is approximately the right number here. 1 up, 1 up. It takes a little while. And let's see, finally, 1 more up. Okay. Now you see that when we get to a 4-component model, should be changing, yes. The residuals look very nice and unstructured, indicating that the model has modeled the systematic variation and left the noise, so to speak, in the residuals. Now, once we are happy or almost happy with the model, we can look into the details of the model.
Yeah, and this you can do by pressing there is a button called View Separate Illusion Profiles, and that will actually show you a different window. This is actually a subplot of the weighted illusion profiles. Here you see 4 component weighted illusion profiles, and this is just a better visualization of those. And why this is important: sometimes when you have a very complex intervals, it's very difficult to look at the superimposed illusion profiles. So from here we can see that component number 1, it is a pig. It has a pig shape which has a very low signal to noise, but it still looks like a pig. And we move to the second one, and that has more better shape, I would say, and it has a higher signal to noise ratio. And the third one, this is actually a tail of the pig which is eluting just before the interval that we investigated. So because it has a different mass spectral profile, so it has been found as a separate component, which is in our case component number 3. And then the last one, the fourth one, it's a baseline. And usually, by the rule of thumb, we always want to model a baseline in GCMS data, because we know there is always baseline which can actually be derived from your either your column and your derivatization reagent you used, or simply this is something to do with your mobile phase. So there will be always baseline, and preferably we always want to model out the baseline. So you look at this pig, you make sure that which is actually a component, which is actually chemical component.
I just want to add one thing. You actually have to know the numbering of the components here, and it starts from left to right. So this is component 1, 2, 3, 4. And you have to remember that, because we're gonna tell the Paradise software which ones are representing real stuff and which ones we don't really care about. We are only interested in the chemical part, for example, component number 2. Because compared to the raw data, you can see that the Parafact2 model has removed the baseline and put that in other parts of the model. So this is a refined version of our peak that we see in the raw data. So that's component number 2. How about component number 1? Would you call that chemical?
Well, it's difficult to define in this case, but what is key to look at here is the mass spectra, and this we can do it just by pressing zoom and trying to zoom in on the component mass spectra, and you can see that 1 is a light blue and 2 is a dark blue, and you can see that the light blue and dark blue, it's slightly difficult to visualize here, but hopefully in the next version of our software we will make a separate subplot of the mass spectral profiles as well. But you can clearly see here there is certain differences in the mass of the first and second components, which simply says that they are not the same chemicals. They have a different mass spectral profile. So we are actually allowed to take into account the first component.
Okay. So what we have done now is that we have established that for this particular peak number 2, we have to use 4 Parafact2 components to model the data, and we have established that component number 1 and component number 2 of this 4-component model are chemical. One really nice thing about Parafact 2 modeling is that it turns out that very often it's not extremely critical to choose the right number of components. It's critical that you're in the right neighborhood, but often it's not critical that you are exactly right. You will still get the chemical information in a robust, reproducible manner. So what we need to do now is to tell the software that we like 4 components, and we do that by just staying at 4 components, and we need to tell Paradise which of these 4 components are we going to use as chemical components. And we do that by pushing the button tag as optimal and clicking 1 and 2. And that's it.
Press
now,
OK.
Yes, now we have told Paradise how to model interval number 2. And we can move on to another peak. And let's see, which one did we have? We had peak number 8. Let's take a look at that one. It takes a little while to load the model, so you have to be a little patient.
Yeah, please keep in mind, in this case you are actually loading 8 different models from 1 to 8 components fitted.
Right. If you look at this, at the raw data here, or the tick, you can see that it does seem like there's some interesting stuff going on here. And already from the visualization of the Parafact 2 illusion profiles, you see that it seems like we can separate that. How many components? Well, we have to be above 2 for sure. Well, maybe not even. It's 99 here on the scale. So basically all of these look nice, I guess. The core consistency says that we can move on for at least up to 5 components. Well, for up to 5 components. So let's try with 5 at first. And the residuals do look nice. We can try and go down to 4 components and monitor how the residuals change by looking in this window here. Not much happens. So maybe 4 or 5 are equally good. Let's take a look at the illusion profiles. So I push the button. Make it a little wider. So what we see is that we get 2 peaks, number 3 and 4, representing chemical information, it seems. And then we get 2 peaks. They look kind of interesting, but they often do, but representing the baseline, I would say.
Yes.
So we can say, let's go for a 4-component model, and let's call component 3 and 4 chemical. So we say tag a 4-component model as optimal, and wait a little bit. Use component 3 and 4 as chemical. Here we are. And you continue doing this. Let me show another one. We can do 41. Where's 41? 41. That's a more complex one. Let's see. Okay, now here you see some interesting things. First of all, you see that this is a very messy interval, and it could potentially be difficult. Maybe it could even be so difficult that it wouldn't work, and maybe you would have to take out a sub-interval. If I had been a little smarter, I guess I would have split this up in 2 intervals or 3 intervals, but I didn't do that. And it accidentally seemed to work out pretty well, I guess. The fit indicates that we need a lot of components, which makes sense looking at the profiles. The core consistency look a little interesting. It's high, but then it dips almost towards 50, and then it increases again. But you have to know that the core consistency is not deemed to change monotonically. So there's nothing wrong mathematically in that it's not monotonic in its behavior. So basically, what this particular core consistency is indicating is that all the models are interesting because all of them are closer to 100 than to 0. And actually even the last one, so component number 8. So that could indicate that maybe I want to go back and also try 9 and 10 components. And I did that for just this interval, and it turned out that these were not interesting. But when you see that the diagnostic indicates that maybe this is not the end of it, maybe there could be more components that were nice, then you can just go back and rerun this with more components. After 7 components, it turns out that the residuals are looking very nice. No structure is left here. So we can try and take a look at this particular one and see the individual illusion profiles. Now there's a lot of stuff going on here, but it's pretty impressive that we do find, it seems, some clear components. For example, this one, number 1. Number 2 we're probably not going to worry about because we don't have the whole peak covered. We just included part of a peak, so that will have to be covered in another interval, and also for this one. But then number 4, number 5, number 6, maybe not number 7. I would probably doubt that that's real chemistry, and if it is, I would want to model it in a separate interval going from around time 90. So maybe 1, 4, 5 and 6. And that's pretty impressive that we can separate 4 different compounds here. We will say tag this as optimal. 1, 4, 5 and 6. Very good. Okay. Now, once you have done that for each and every interval, you're basically done. And that's the hard work here. But it doesn't take more than an hour or so once you have some experience with it. So in total you may have to spend maybe 2 hours in total on resolving your data.